In this screencast, we introduce conditional statements. In previous screencasts, we discussed using logical operators such as conjunction, disjunction, and negation to create compound statements. Now we will learn a new logical operator called a conditional or an implication. The definition of a conditional statement is as follows. If P and Q are sentences, a conditional statement or implication is a compound statement that can be written as if P, then Q. We also might say P implies Q. P is called the hypothesis and Q is called the conclusion. The conditional is false only when P is true and Q is false. You'll see our notation for the implication is a double-tailed arrow that we see here, but in mathematical logic, an implication is often seen with a single-tailed arrow, as you see below the definition. However, in mathematical proofwriting, the double-tailed arrow is what we use. To hopefully prevent any confusion later on, we will only use the double-tailed arrow in these screencasts. Let's consider the following example. Suppose P is the phrase, "It is raining." Let Q be the phrase, "Johnny will stay home." Then the conditional statement is, if it is raining, then Johnny will stay home. The only time this is false is if it is raining and Johnny does not stay home. Certainly it is true if it is raining and Johnny does stay home. However, if it is not raining, then it does not matter what Johnny does. The statement will still be true. The conditional statement is defined as an if-then statement. However, there are many ways of phrasing this. The main idea of a conditional statement is that if certain conditions are met, then something must happen. There are many ways to express this in the English language, and all of them are acceptable within mathematical proofs. For example, we could say if P then Q, or P implies Q. We could also say that P is sufficient for Q, and Q is necessary for P. We may say that whenever P is true, Q is also true. There are other ways to say this. We could say Q if P, and P only if Q. Again, all of these are acceptable within the English language, and therefore acceptable within mathematical proofs. Let's again revisit the example we were looking at before, and P and Q are the same statements that they were previously. The conditional statement, P implies Q, can be written in many different ways. The important thing is to make sure that it makes sense within the English language and gets across the idea that if certain conditions are met, then something must happen. We could phrase the implication as, if it is raining, then Johnny will stay home, or it is raining implies Johnny will stay home, or because it is raining, Johnny will stay home, and Johnny will stay home if it is raining. And of course there are other ways to phrase it as well. Here is the truth table for a conditional statement. Again, in the definition we say that a conditional statement is only false when P is true and Q is false. And you see that here in the second row of this implication. If P is true and Q is false, the implication is false. In all other combinations, the implication or the conditional statement will be true. Let's consider the following example. Throughout all of these, let's let x be a real number. Now I suggest that you pause the video and determine if the following statements are true or false. To get the solution to this problem, we simply remember that for a conditional statement to be false, the hypothesis must be true and the conclusion must be false. If we look at example A, we see that the hypothesis 2 plus 2 equals 4 is a true statement. However, the conclusion 2 is greater than 5 is a false statement. Therefore, this conditional statement is false. When we move on to example B, we see that the hypothesis 2 plus 2 equals 5 is a false statement. Since the hypothesis is false, it does not matter what the conclusion is. This is a true statement. For example C, if x plus 1 equals 3 is going to be true, that would mean that x has to equal 2. So if x plus 1 equals 3 is true, then 2 is greater than 5. If the hypothesis is true and the conclusion is false, this would be a false statement. Now looking at example D, x plus 3 equals 6 implies that x is less than 5. If x plus 3 equals 6 is true, that would mean that x equals 3. And 3 is certainly less than 5. So when the hypothesis is true, the conclusion is also true, making this a true statement. So the only times that we were getting false statements were A and C, and B and D will be true statements.